Okay, today we are going to start our probability unit out of really performing different probabilities by learning how to design a simulation that we can use to represent real-world situations and find out experimental probabilities using simulations. So a simulation is an experiment performed to make predictions about real-world situations. So we're going to be working with designing simulations to help represent real-world situations so that we can find experimental probabilities without always having to go perform those activities. So in designing a simulation, you have to state the problem. So we have to figure out, what are we representing? So we have to have an understanding of what you are modeling. So once you know and understand what you're going to be modeling, the second step is to state your assumptions. What do you assume to be true about this situation? Then, once you have your assumptions and you know what's going to be true about the situation, your next step is to pick a model. How will you represent the situation? So that means, what are you going to use to represent that situation? What are you going to use to figure out the different outcomes? So once you have figured out how you're going to model the situation, then you need to actually perform that simulation. So once you've gotten the model done and you've figured out what a favorable outcome is, you're going to simulate multiple trials. And you have to figure out how many trials do I need to represent the situation. Once you've performed all your trials, then you're going to interpret your results. So now you're going to think about, what do those results mean? What did I find out by performing that simulation? So carrying out a simulation, the tools. You can use a variety of tools or methods to carry out a simulation. Here are a few. So some of the common tools that you might use to create a simulation would be those tools that we use in our experimental and theoretical probability problems. So you might use coins. You might use dice. You might use cards, marbles, a random number generator, or you might use a spinner. These are all different things you might use to represent that simulation, but you have to have it match up with the type of real-world situation that you are going to use it for. So like coins only work for a 50-50 chance of something happening. Dice you can manipulate a little bit more. You can use it for 50-50 by doing evens or odds. You can do it for a 6 outcome, for 1/6. Cards, there's several different ways you could run card simulations. Marbles is a little bit more adjustable, but you have to think about that theoretical probability when you are creating a simulation in order to choose the right tool. So let's look at some different simulations that we could create. So design simulations and use the results of the simulations to make predictions. So looking at the simulation, based on theoretical probability, Melissa has the chance to either make or miss a basket when playing basketball. To simulate this, she flipped a coin 100 times. Based on the results of her simulation, she should make a basket 54 times out of 100 shots. Do her results of her simulation seem logical? Explain why or why not. So I want you to think about it a little bit. Does this simulation match up with the real world situation? Does it make sense that she would make 54 shots out of 100? So I would say no, this is not a very good simulation, because this one is a little bit harder because there's a lot of other factors that go into sports and basketball than just making and missing. You want to think about her skill level, and this one you might need to perform more of an actual experimental probability to figure out more of her actual theoretical probability than just make or miss before you could actually create a simulation for the situation. Number 2, a test of 20 multiple choice questions. Each question has 3 choices, only one of them being the correct answer. Design a simulation that you could use to predict the test score of someone who guesses on each of the questions. So that's the important piece right there, is that they guess on each of the questions. So that takes out all their knowledge of the materials. So that gives us a what probability of getting each question right. So it gives us a 3 out of 4 chance, or 1 out of 4 chance of getting it correct. And a 3 out of 4 chance of getting it wrong. So that means we have to design a simulation that has a 1/4 chance of a correct answer and a 3/4 chance of getting it incorrect. So I would say one of the easiest simulations for this would be a spinner split up into fourths, where one of them is correct and the other 3 are wrong. Or you could use a deck of cards, since they are 4 different suits. And you could say hearts are correct, all other suits are wrong. So you need to set up a simulation that would have a 1/4 versus 3/4 probability of right and wrong. Number 3, would the results of a simulation be considered theoretical or experimental? Explain. So I talked about this a little bit earlier. So what do you remember? Is it theoretical or experimental, and why? The answer is experimental. Because we are actually performing something that gives it that real world aspect. And number 4, Kevin plays soccer. He has been scoring a goal 40% of the time. So this one's already different than number 1 because we have that ability level built in already. So design a simulation that could be used to predict the number of goals he could make out of the next 300 shots. So we have to think about what could we use that would give us a 40% chance. So what is a good fraction that equals 40%? So we can think of 4 out of 10, which equals 2/5. So that means 2/5 of the time he makes, and 3/5 he misses. So this might be one that you set up with marbles, and you do 2 green marbles and 3 red marbles. Or you could do a spinner again and have 5 equal sections. 2 are makes, 3 are misses. You could do let's look back up here. Could do dice would be kind of hard. Cards, you could probably figure out a situation, but the 2 easiest ones are probably going to be the spinner or the marble, something that is easily manipulated to have 5 outcomes as your total. So today for your assignment, you're going to work on coming up with different options to come up with different experimental probabilities, and then you're going to also be analyzing a few different simulations.